Hey, hi everyone, welcome back to this video series on Windows Server 2012 IPv6 addressing concepts. You need to consider several concepts when using IPv6 addressing. For starters, the format of the address has changed. Three types of addresses are used in IPv6 with some predefined values within the address space. You need to get used to seeing these addresses and be able to identify their uses. IPv6 address format. For the design of IPv4 addresses, you present addresses as octets or the decimal base 10 representation of 8 bits. 4 octets add up to the 32 bits required. IPv6 expands the address space to 128 bits, and the representation is for the most part shown in hexadecimal, a notation used to represent 8 bits using values 0, 9, and AF. Figure 8.13 compares IPv4 to IPv6. A full IPv6 address looks like the example. So 20000000:A9FE:0000:133E. You can tell the implementation of DNS will make life a lot easier, even for those who like to ping the address in lieu of the name. Fortunately, DNS already has the ability to handle IPv addresses for use of an AAA record. A is short for alias. An A record in IPv4 addressing space is 32 bits. So an A record or 4 A's is 128 bits. The Windows Server 2012 R2 DNS server handles the A and the reserve pointer PTR records for IPv6. So you can see here in figure A13, the IPv4 to IPv6 comparison. IPv4 address shortcuts. There are several shortcuts for writing an IPv6 address. These are described in the following lists. So colon, 0 : stands for : 0000. You can omit preceding zeros in any 16-bit word. For example, :db8, :0db8 are equivalent. Double colon is a variable standing for enough zeros to round out the address to 128 bits. Double colon can be used only once in an address. You can use these shortcuts to represent the example address 2001 : 0D AB8 : 0000:00:12 34 : 0000:A9FE: :133E as shown here, compressed. Okay, so : 0 : 0 : 0 : into : 0 : 201 : 0db8 : 0 : A9FE: :133E. Eliminate the preceding zeros. 2001 : db8 : 0000: 0 : 0 : A9FE: :133E. use the special variable shortcut for multiple zeros 2001 colon DB8 double colon 123 4 colon 0 colon A9FE colon 133E. You can now also use prefix notation or slash notation when discussing IPv6 networks. For example, the network of the previous address can be presented as 2001 colon DB8 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000. This can also be expressed as 201 colon DB8 double colon /32. The /32 indicates 32 bits of network, and the 2001 colon DB8 colon is 32 bits of network. IPv6 address assignment. So, do you know subnet IPv6? The answer depends on your definition of subnetting. If you are given 32 bits of network from your ISP, you have 96 bits with which to work. If you use some of the 96 bits to route within your network infrastructure, then you are subnetting. In this context, you do subnet IPv6. However, given the huge amount of bits you have available, you will no longer need to implement VLSM. For example, Microsoft has a network space of 2001 colon 4898 double colon /32. That gives the administrators a space of 96 bits. 296 equals 79 228 169 514 264 337 593 543 950 336 unique addresses using all 96 bits with which to work. You can let Windows Server 2012 R2 dynamically, automatically assign its IPv6 address, or you can still assign it manually. See figure 814. With dynamic automatic assignment, the IPv6 address is assigned by either a DHCPv6 server or by the Server 2012 R2 machine. If no DHCPv6 server is configured, the Windows Server 2012 R2 machine can query the local LAN segment to find a router with a configured IPv6 interface. If so, the server will assign itself an address on the same IPv6 network as the router interface and set its default gateway to the router's interface IPv6 address. Figure 8.14 shows that you have the same dynamic and manual choices as you do in IPv4. However, the input values for IPv6 must conform to the new format. So you can see here figure 8.14 TCP IPv6 properties Windows. To see your configured IP addresses IPv4 and IPv6, you can still use the ipconfig command. For example, I have configured a static IPv4 address and an IPv6 address on my server. The IPv6 address is the same as the one used in the earlier IPv6 example address. Figure 8.15 shows the results of this command on a Windows Server 2012 R2 for my server. So IPv6 address types. As stated earlier, there are 3 types of addresses for IPv6: Anycast, Unicast, and Multicast. A description of each of these types of addresses follows. Anycast addresses are not really new. The concept of Anycast existed in IPv4 but was not widely used. An Anycast address is an IPv6 address assigned to multiple devices, usually different devices. When an Anycast packet is sent, it is delivered to one of the devices, usually the closest one. Unicast addresses. A unicast packet uniquely identifies an interface of an IPv6 device. The interface can be a virtual or a pseudo interface or a real physical interface. Unique addresses come in several types, as described in the following list. Global unicast address. As of this writing, a global unicast address space is defined as 200:3. The 2001:32 networks are the IPv6 addresses currently being issued to business entities. As mentioned, Microsoft has been allocated 2001:4898:32. A Microsoft DHCP v6 server will be set up with scopes ranges of addresses to be assigned within this address space. There are some special addresses and address formats that you will see in use as well. You'll find most example addresses listed as 2001:DBA:/32. This space has been reserved for documentation. Do you remember the loopback address in IPv4 127.0.0.1? In IPv6, the loopback address is :1 or 0:0:0:0:0:0:0:0:0:0:0:1. You may also see an address with dotted decimal used. A dual stack Windows Server 2012 machine may also show you FE80:5E:192.168.1.200. This address form is used in an integration/migration model of IPv6. Linked local addresses as defined as FE80:10. If you refer to figure 8.15 showing the ipconfig command, you will see the link local IPv6 address as FE80:AB:9D:7DA4:CCBA. The last 8 bytes, 64 bits, are random to ensure a high probability of randomness for the link local address. The link local address is used on a single link network segment and should never be routed. There is another form of the local link IPv6 address called the Extended User Interface 64-bit EUI64 format. This is derived by using the MAC address of the physical interface and inserting an FFFE between the third and fourth bytes of the MAC. The first byte is also made 02. This sets the universal local or UL bit to 1 as defined in IEEE 802 frame specification. Again, looking at figure 8.5, the EUI64 address would take the physical MAC address 000FF1102CD and make the link local IPv6 address FE80 double colon 0203 colon FF colon FE11 colon 02CD. I've left the preceding zeros in the link local IPv6 address to make it easier for you to pick out the MAC address with the FFFE inserted. Anonymous address. Microsoft 2012 R2 uses the random address by default instead of EUI64. The random value is called the anonymous address in Microsoft Server 2012 R2. It can be modified to allow the use of EUI64. The unique local address can be FC00 or FD00, and it is used like the private address space of IPv4 or FC4193 describes unique local addresses. They are not expected to be routable on the global internet. They are used for private routing within an organization. Multicast addresses are one-to-many communication packets. Multicast packets are identifiable by their first byte, most significant byte, leftmost byte, leftmost 2 nibbles, leftmost 8 bits, and so on. A multicast address is defined as FF00 double colon /8. In the second byte shown, the 00 of FF00, the second 0 is what's called the scope. Interface local 01 and link local is 02. FF01 double colon is an interface local multicast. There are several well-known already defined multicast addresses. For example, if you want to send a packet to all nodes in the link local, you send the packet to FF02 double colon 1, also shown as FF02 colon 0 colon 0 colon 0 colon 0 colon 0 colon 0 colon 1. The all router's multicast address is FF02 double colon 2. You can also use multicasting to get the logical link layer address, MAC address of a device with which you are trying to communicate instead of using the ARP mechanism of IPv4. IPv6 uses the ICMPv6 neighbor solicitation NS and neighbor advertisement NA messages. The NS and NAICMPv6 messages are all part of the new neighbor discovery protocol NDP. This new ICMPv6 functionality also includes router solicitation and router advertisements, as well as redirect messages similar to the IPv4 redirect functionality. Table 8.7 outlines the IPv6 address space, known prefixes, and some well-known addresses. So we'll just go through this quickly. Table 8.7 IPv6 address space, known prefixes and addresses. Address space scope of use 2000 double colon /3 global unicast space prefix FE80 double colon /10 link local address prefix FC00 double colon /7 unique local unicast prefix FD00 double colon /8 unicast local unicast prefix FF00 double colon 8 multicast prefix 2001.db8 double colon /32 global unicast prefix used for documentation double colon 1 reserved local loopback address 2001 /32 Teredo prefix discussed later in this chapter, 2002 /16 6 to 4 prefix. IPv6 integration migration. It's time to get into the mindset of integrating IPv6 into your existing infrastructure with the longer goal of migrating to IPv6. In other words, this is not going to be an okay Friday. The internet is changing over rollout. You have to bring about change as a controlled implementation. It could easily take 3 to 5 years before a solid migration occurs, and probably longer. I think the migration will take slightly less time than getting the world to migrate to the metric system on the overall timeline. The process of integration and migration consists of several mechanisms. Dual stack, simply running both IPv4 and IPv6 on the same network, utilizing IPv4 address space for devices using only IPv4 addresses and utilizing the IPv6 address space for devices using IPv6 addresses. Tunneling, using an encapsulation scheme for transporting one address space inside another. Address translation, using a higher level application to change one address type IPv4 or IPv6 to the other transparently so that end devices are unaware one address space is talking to another. IPv6 dual stack. The default implementation in Windows Server 2012 R2 is enabled IPv6 configuration along with IPv4. This is dual stack. The implementation can be dual IP layer or dual TCP IP stack. Windows Server 2012 R2 uses the dual IP layer implementation when an application queries a DNS server to resolve a hostname to an IP address. The DNS server may respond with an IPv4 address or an IPv6 address. If the DNS server responds with both, Windows Server 2012 R2 will prefer the IPv6 address. Windows Server 2012 R2 can use both IPv4 and IPv6 addresses as necessary for network communication. When looking at the output of the IP config command, you will see both address spaces displayed. IPv6 tunneling. Windows Server 2012 R2 includes several tunneling mechanisms for tunneling IPv6 through the IPv4 address space. They include the following: intra-site automatic tunnel addressing protocol ISATAP, which is used for unicast IPv6 communication across an IPv4 infrastructure. ISATAP is enabled by default in Windows Server 2012 R2. 6 to 4, which is used for unicast IPv6 communication across an IPv4 infrastructure. Teredo, which is used for unicast IPv6 communication with an IPv4 NAT implementation across an IPv4 infrastructure. With multiple tunneling protocols available and enabled by default, you might ask, what's the difference and why is one used over the others? They all allow you to tunnel IPv6 packets through the IPv6 address space. Here are some details of the tunneling mechanisms. ISAP, intra-site automatic tunnel addressing protocol. ISATAP is the automatic tunnel addressing protocol providing IPv6 addresses based on the IPv4 address of the end interface. The IPv6 address is automatically configured on the local device, and the dual stack machine can use either its IPv4 or its IPv6 address to communicate on the local network within the local network infrastructure. ISATAP can use the neighbor discovery mechanism to determine the router ID and network prefix where the device is located, thus making inter-site communication possible even in a routed infrastructure. The format of an ISATAP address is as follows: 64 bits to prefix, 32 bits indicating ISATAP, 32 bits IPv4 address. The center 32 bits indicating ISATAP are actually 0000:5EFE when using private IPv4 addresses. The ISATAP address of the example Windows Server 2012 R2 machine using the link local IPv6 address is FE80:5EFE:192.168.1.200. Each node participating in the ISATAP infrastructure must support ISATAP if you're routing through an IPv4 cloud. A border router, a router transitioning from an IPv6 to IPv4 space, must support ISATAP. Windows Server 2012 R2 can be configured as a border router and it will forward ISATAP packets. ISATAP is experimental and is defined in RFC 4214. 6-4 specifies the procedure for IPv6 networks to communicate with each other through an IPv4 space without the IPv6 nodes having to know what's happening. The IPv6 nodes do not need to be dual stacked to make this happen. The border router is the device responsible for knowing about the IPv6 to IPv4 transition. The IPv6 packets are encapsulated at the border router and decapsulated at the other end or on the way back. There is an assigned prefix for the 6-4 implementation: :2002:/16. 6-4 is defined in RFC 3056. Teredo is a protocol designed to allow IPv6 addresses to be available to hosts through one or more layers of NAT. Teredo uses a space of tunneling packets through IPv4 space using UDP. The Teredo service encapsulates the IPv6 data within a UDP segment packet and uses IPv4 addressing to get through the IPv4 cloud. Having a layer 4 transport layer available to use as translation functionality is what gives you the ability to be behind a NAT, which is network address translation. Teredo provides host-to-host communication and dynamic addressing for IPv6 nodes dual stack, allowing the nodes to have access to resources in an IPv6 network and the IPv6 devices to have access to the IPv6 devices that have only connectivity to the IPv4 space, like home users who have an IPv6 enabled operating system connecting to IPv6 resources, while their home ISP has only IPv4 capabilities. Teredo is defined in RFC 4380 on Windows Server 2012 R2. An IPv4 Teredo server is defined and configured using the NETSH command interface. The Teredo server provides connectivity resource address to the Teredo client. The node that has access to the IPv4 internet and needs access to an IPv6 network internet. A Teredo relay is a component used by the IPv6 router to receive traffic destined for Teredo clients and forward the traffic appropriately. The defined prefix for Teredo addresses 2001:0000:32. Teredo does add overhead like all the other implementations discussed. It is generally accepted that you should use the simplest model available. However, in the process of integration migration, for most of us behind a NAT, Teredo will be the process to choose. For Windows Server 2012 or to use the ipconfig/all command to view the default configuration, including IPv4 and IPv6, you may notice a notation that I didn't discuss. The %sign at the end of the IPv6 address, the number after the %sign is the virtual interface identifier used by Windows Server 2012 or 2. So you see here figure 8.7 IPv6 identifier for ipconfig display. So I'm going to do it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.